In previous video, I have discussed about basic concepts of per unit system, or you can say how you will convert any power system quantity in per unit, and what are the advantage of the representation of power system quantity in per unit system. This thing I have already discussed in the previous video. As I have discussed, suppose any quantity A, any power system quantity A, which is given in conventional unit, and if you want this quantity in per unit, then how you will convert conventional unit in per unit? So there is a basic formula, and which is per unit value of any power system quantity is the ratio of its actual value to its base value. And you must remember here the actual and base value should be of same dimension. So per unit quantity will be a dimensionless quantity. So first I have discussed about the basic definition of per unit representation, per unit system, how you will convert any conventional unit in per unit. Second thing which I have discussed in the previous video is about the base value, how you will select base value for a particular power system quantity. About this, however, you can select any value, 10 MP, 10, 100, any round figure as the base value for a given power system quantity. But the convention is to consider base value from the rating of the machine. Usually, rating of the machine is considered as the base value for that quantity. Second thing which I have discussed in previous video, how you will convert impedance, which is given in conventional unit, and the task is to convert impedance in per unit. How you will convert impedance, which is in ohm, and the task is to convert this ohm in per unit. So the formula which I have derived in previous video is the per unit value of the impedance is its actual value into SB divided by VB square. This is very important formula. Here SB is base value of volt ampere and VB is the base value of the voltage. And from where you will take these two value, already I have stated, these two value you will have to consider from the rating of the machine. On machine, these two value are usually given, and impedance value is given in ohm. Then by using rating of the machine, you can convert ohm in per unit. So this formula is very important. You must remember this formula. And in this video, in this lecture, I will use this formula to show the advantage of per unit system when you will represent reactance, resistance, or impedance of the transformer in per unit. What will be the advantage when you will represent transformer impedance in per unit? So this formula is very important for today's discussion. So you must remember this formula. Z per unit is the actual value of Z into SB. SB is the uh, volt ampere rating of the machine, and VB is the voltage rating of the machine. So now let us consider a single phase transformer here, and its number of turn in primary winding is N1 and number of turn in the secondary winding is N2. Z1 and Z2 are the primary and secondary impedance. V2 and V1 are rated primary and rated secondary voltage, and I1 and I2 are the rated primary and secondary current. Now the task is to calculate total impedance of the transformer referred to the primary And here, if impedance is given in ohm, then what will happen? When impedance is given in ohm and the task is to convert total impedance of the transformer referred to the primary, then how you will convert, how you will calculate the total impedance of the transformer in first year or in machine course. Already you have an idea of this. Uh, the total impedance of the transformer referred to the primary will be the primary impedance plus secondary impedance referred to the primary. So Z1E here is total impedance of the transformer referred to the primary, which will be equal to Z1 primary impedance and secondary impedance referred to the primary. Already you know about this formula. And if I am asking you now calculate total impedance of the transformer referred to the secondary, then it will be equal to the secondary impedance plus primary impedance referred to the secondary. This is primary impedance referred to the secondary. Here N1 and N2 are the number of turn in primary and secondary winding. So clearly you can see here Z1E and Z2E are not equal because transformer will be either a step up or step down. If N1 and N2 are not equal, then these two values are also not equal. Transformer impedance referred to the primary and transformer referred to total impedance of the transformer referred to the secondary will not be equal if turn ratio are not equal. So you must remember. And also you know about the turn ratio. Turn ratio N1 by N2 under some assumption it will be equal to V1 by V2 and also it will be equal to I2 by I1. So you must remember this. So what you are seeing here, the impedance of the transformer referred to the primary and impedance of the transformer referred to the secondary are not equal to each other, and it depends on the turn ratio. Now, what will happen when you will represent impedance in per unit? Z1 and Z2 will be in per unit, then what will happen? What change will happen here? So now I'm going to calculate impedance of the transformer in per unit. Suppose you want to calculate impedance of the transformer referred to the primary in per unit. So using this formula, the formula is if you want to convert impedance which is given in ohm and if you want to convert this in per unit, then the formula is actual value of impedance into SB divided by VB square. Just I am going to use this formula. So Z1E per unit is total impedance referred to the primary in per unit. It will be equal to the actual impedance into SB divided by VB square. So this formula is very important. And what is Z1E from here? You can take the value of Z1E. Z1E is the total impedance of the transformer referred to the primary, which is equal to Z1 plus Z2 N1 by N2 whole square. So in place of Z1E, you can write this. And SB by VB square. Now, the important thing, what is SB? SB is volt ampere base and VB is voltage base, which you will have to take from the rating of the machine. So if primary voltage is V1 and primary current is I1, then for the primary side, SB will be V1 into I1 and base value will be V1. So you will have to take primary data and secondary data as the base value. So in place of SB, you can write V1 I1 and in place of VB, you can write V1 because you are calculating the impedance value referred to the primary, and for the primary side, SB is V1 I1 and voltage base is V1. So you can get this value. And so in place of SB, you can write V1 I1. And in place of VB, you can write V1. Now V1 and V1 will cancel each other. So the term will be this. Now you can multiply I1 by V1 in both the term. So you will get this value. Z1 into I1 by V1 and Z2 into N1 by N2 whole square into I1 by V1. So you can get this value. Now you will have to use this relationship. Now what is I1? From here you can see I1 is I2 N2 divided by N1. So this is I1. And what is V1? From here you can see V1 is N1 V2 N1 V2 divided by N2. So this is V2. Sorry, V1. So in place of I1, you can write this term. And in place of V1, you can write this term. Plus Z2 N1 by N2 whole square. In place of I1, you can write this. And in place of V1, you can write this. Now you will have to solve this expression. What you will get? So first term you will get like this. Z1 N2 will be N2 square and N1 square I2 and V2. You will get this term. And here N2 square and N1 square will cancel each other. So you will get this term. Just this is a mathematical simplification. Easily you can get this term. Now you will have to take I2 and V2 common. I2 by V2 common. You will get this term. And what is this? This is Z2 plus Z1 N2 by N1 whole square is the impedance of the transformer referred to the secondary. So in place of this, you can write Z2. You can write Z2 into I2 by V2. Now you can multiply V2 in numerator and denominator. You will get I2 V2 here and V2 square here. And what is I2 V2? I2 V2 is the base value of S for the secondary side. Base value of S for the secondary side is V2 into I2. And what is V2? V2 is the base voltage for the secondary side. So in place of V2 I2, you can write SB. And in place of V2, you can write VB. So you will get this expression. Actual value of total impedance referred to the secondary into SB divided by VB square. So what is this? This is per unit value of secondary impedance, total impedance referred to the secondary. So in this way, you can see Z1E. I have started calculation from here and now I am getting this. So you can see Z1E per unit will be equal to Z2 per unit. So when you will represent transformer impedance in per unit, then what you are analyzing here, the total impedance of the transformer referred to the primary and total impedance of the transformer referred to the secondary will equal to each other. So this is the advantage when you will represent transformer reactance in per unit. Referred value total impedance of the transformer does not depend on the turn ratio. If total impedance of the transformer referred to the primary is 0.5 per unit, for example, then for the same transformer, total impedance referred to the secondary will also be 0.5 per unit. So here total impedance of the transformer referred to primary will be equal to total impedance of the transformer referred to secondary if impedance value are given in per unit. You must remember here it is Z2E per unit. Z2E per unit. So this is one advantage. And second thing, you can see in this slide, what will be the value of per unit value of this impedance plus per unit value of this impedance. Z1E per unit means per unit value of primary impedance, and Z2 per unit means per unit value of secondary impedance. What will happen when you will add these two impedance? So in this slide, you can see if you will add these two impedance, then what will be the final result? So this formula is very important. If you want to convert Z in per unit, its actual value SB by VB square. This formula is very important for this chapter. So what will be the value of Z1 per unit? Z1 per unit will be its actual value into SB by VB square. And what will be the value of Z2 per unit? Z2 per unit will be its actual value SB by VB square. And for primary side, for this Z1, SB will be V1 I1 and VB will be V1. And for Z2, secondary side, SB will be V2 I2 and VB will be V2. So you must remember, you must note this point. So you can get this value. Now V1 and 1 V1 will cancel from here and V2 and 1 V2 will cancel from here. You will get this result. You will get this result. And when you will take I1 by V1 common, then here you will get Z1 and in second term you will get Z2 I2 by V2 into V1 by I1. And again from this turn ratio, you can write I2 by I1 equal to N1 by N2 and V1 by V2 will also be equal to N1 by N2. So you will get Z1 plus Z2 N1 by N2 whole square. And what is this? This is total impedance of the transformer referred to the primary. So in place of Z1 plus Z2 into N1 by N2 whole square, you can write Z1E. And again, you can multiply V1 in numerator and denominator, you will get this term. And what is V1 I1? It is volt ampere rating, SB. And what is V1? V1 is the base value for the primary side. So you will get Z1E into SB by VB square. And what is this? This is Z1E per unit. And already you have seen Z1E per unit is equal to Z2E per unit. So in this way, you can say the sum of these two, reactance, impedance or resistance, if it is in per unit, then sum of primary impedance and secondary impedance will be equal to total impedance of the transformer, either referred to the primary or referred to the secondary. So this is very important. So suppose I am asking you one question. The question is, suppose the value of Z1 is, suppose I am asking you one question for better understanding of this concept. Suppose Z1 is 0.5 per unit and Z2 is 0.2 per unit. And I am asking you, calculate the value of total impedance of the transformer referred to the primary. So simply what you will do, you will have to just add these two. So total impedance of the transformer either refer to the primary or refer to the secondary will be just equal to sum of these two reactance, 0.5 plus 0.2, 0.7 per unit. So this is the advantage when you will represent transformer reactance, resistance, impedance in per unit. So in next lecture, I will discuss some numerical example based on this concept.